Hey, this is Ronald from Mass Hills University. This is a Goodman furnace, and I absolutely love Goodman furnaces. And I've had 4 different types of furnaces, even high efficiency ones, and this is not one of those. But I talked to friends of mine who are in the HVAC business, and one is retired. He's like, no, Goodman, man, they run, they work, and if we need a part, they're relatively inexpensive and easily accessible. And I'm going to show you where things are, but more importantly, I'm going to show you the sequence of operation. What I love about this furnace, or furnaces in general, is that each step and each component has to work for it to go forward. Otherwise, it cuts off. Now, if there's any types of errors in a furnace, that thing blinks if there's some type of error in your machine. And unlike a washing machine, it tells you exactly what it is, pressure switch or whatever. Sometimes in these furnaces, your technical diagram chart will be tucked inside. You can look around for that. On a side note, I took this Armana washing machine apart because it stopped draining, figured out reset code, and I also show you the sequence of operation for this Armana washing machine, or for the most part, any top-load Whirlpool style washing machine. I also did the same for this Armana dryer. Now we're back over here at the furnace, but keep in mind, any kind of appliance, washer, dryer, they have a lifespan of 3 to 5 years, and you're going to have to replace components. So we're going to assume that the power's on, and we're going to pretend upstairs that the thermostat is set to 60 degrees, and it drops to 59, which means there'll be a call from the thermostat to the control board, right, which is down there. Okay, we're upstairs. These are just a few of the different types of furnaces out there. I've owned a Carrier, a Lennox, a Rheem, and now a Goodman. This is the operational sequence for a basic furnace. And this is what that looks like. Control panel is going to be right there. The inducer motor is going to be up in there. You're going to have a pressure switch over here. Igniter switch is going to be there. Your flame sensor could be on the opposite side of your ignition switch on this side, but your manual will tell you where it's at. Find your manual. You want to find your diagnostic chart so you'll know how things are laid out and how to find whatever component you're looking for. You also are going to want to know the electrical readings and requirements for each of these components in case you want to test them yourself. With that said, we have a call for heat number 1 because we're at 59 degrees. The thermostat is hardwired to your control panel. There's going to be a slight delay, but number 2, the control panel takes the call for heat. Number 2, the control panel at that point tells the inducer motor. Number 3, the inducer motor starts creating that draft and doing its job to get the combustible gases out. If that goes okay, you'll hear a click because all of these pieces are mechanical. Then it tells number 4, the pressure switch or switches. You may have 2, especially if you have a high efficiency furnace. The pressure switch closes, then it tells number 5, the igniter, to ignite. That bright orange or red glow you're going to see on one side of your burner. That bright light's going to come on. The igniter works. Then number 6, the gas valve is going to start letting in gas. You will hear a click and you'll hear that gas coming in. And then number 7, the burners will come on. You may have 4, you may have 6. At that point, number 8, the flame sensor will let the control panel know that there is flame. In that case, number 9, the heat exchanger will start warming that air up. So number 10, the blower motor can blow that air into your unit. Okay, let's do a process of elimination using our operational sequence knowledge. Number 1, we have a call for heat. If nothing happens here, you can pop this off and jump it right here. And if it works, you know it's the thermostat. You can also jump it right here on the control panel. You can also order a similar one so you don't have to mess with the wires. Pop it on. If it works, then you know it's the thermostat, it's the control panel. If that works, then we go to the inducer motor. That's what you hear when your furnace first kicks on. Starts to create the draft. And there will be a click. Then there'll be another click on the pressure switch or switches. And you'll hear that when they close. Then you'll hear the igniter ignite and you'll see that glow in your furnace. If you don't hear those clicks, or if you don't hear that furnace come on, then I would start looking at the inducer motor. Sometimes things happen and these pressure switches get stuck either open or closed, in which case you're going to have to replace it. If you don't get a glow, then you know that something's wrong with the igniter. You can take your meter out and check this and see what the readings are, or do that for any of these components. You will hear the gas valve click on and the gas start coming through. And then of course your burners should all light up. You may have 4 burners, 6 burners. They vary according to your model. Sometimes the gas pressure is set too high. Sometimes your gas line spikes it. It should be at around 3.5. And the great thing about it is at each step, if something does go wrong, you'll get blinking lights down here and they'll blink to a code like blink, blink, pause, blink, pause, blink, pause, blink, blink, something like that. And they'll correspond, if you look on your diagnostics chart, to a specific component in your furnace. So if these burners come on, you'll hear them, they'll light up, then you know that's working. If they light up and then within a few seconds they die or go off, you have a dirty flame sensor, which is probably the #1 call for HVACs all over the world. And it's just a metal rod. And then of course, your heat exchanger. These heat exchangers do crack. They could lead to carbon monoxide poisoning. And if they crack, you should replace it and or the furnace. And then your blower. Everything works and then it just doesn't blow. Then it's probably your blower. And these things do die as well. If we looked at some of the components or some of the common problems and solutions or possible solutions, I would have this in mind. So here's our recap of our sequence of operation. Biggest culprit for any of these things failing down the line is having a dirty filter, one that you don't change or you change 2 or 3 times a year. That's going to put stress on all of the other components inside your furnace. Furnace life is about 5 years before you have to start changing some of these components. So let's keep our filters clean, change them every other month. That's why they come in 6-packs. But a mistake that people make with filters is buying cheap filters that let too much in. Try to find an in-between filter and then make sure you insert it correctly so it's taking the air up and out or out of your furnace and not blocking it in. I've seen these things put in backwards and that creates airflow problems, and that's a big issue. The biggest service call probably in the HVAC industry is for a dirty flame sensor. These things are metal rods. They're not really replaceable. Just take a dollar bill or any relatively new bill, and I'm sure it works in different countries too, or either take one of those green pot scrubber pad things and just scrub it and get the dirt out. Because remember, that flame sensor has to verify to the control board that there is flame. And if it can't do it because it's dirty, between 3 to 5 seconds, your furnace will shut down. It's going to try to restart, then it's going to shut down. It always tries to do this sequence 2 or 3 times before it goes into a shutdown for 3 hours. So that's how that works. In terms of what can fail or what has to be maintained, the inducer motors, they die, but if you keep your filters clean, it's going to really help the longevity of your inducer motor. Blower motors, they die too. That's another thing you want to keep an eye on. Airflow is a big deal. And when you first start the furnace, your rollout switch, that's a safety switch, is going to, of course, do its safety checks. But limit switches are always checking for heat and different things. This switch right here is triggered a lot if you have a dirty filter, if you don't clean your second heat exchanger. There are fans that go out. There are small fans that are around your motors. You want to keep those clean and make sure they operate. If you do trip these things, sometimes you can just kind of tap it to get it to work again. Otherwise, you can just replace these. The in-shot burners, you normally have 4 or 6 of these, but these get dirty and clogged up. And again, if you don't change your filters, it gets even worse. And this causes problems as well. So keep those clean, kind of air them out, take a wire brush, clean them out. Your pressure switches, they get stuck sometimes on open and closed. If that happens, you just have to replace it. Not much you can do. Your gas valves, you have to replace those sometimes. And normally if you put in a new gas valve, you have to set the pressure to about 3.5 or take. Just do some research on that. Look at your manual, but you need to adjust that gas pressure. And that could cause errors as well. And these are just some of the things that you need to look out for. If your furnace keeps going out, look at your flame sensors and then look out for things that restrict the airflow. Anything that restricts the airflow. Anything you have to do, I'm sure there are tons of YouTube videos out there. Thank you very much for watching. If you have any questions, ideas, suggestions, please leave them below. Please like, share, and subscribe. And until we meet again, I'm wishing you and yours a great 2025. Peace.